Okay, we're going to look in this video at partial fractions, which is the first topic of A21. Now, a partial fraction is basically where you start off with something in this form, and you have to get it back to this form. So there's a method for this. We can see how it works going this way around from here to here, where you have two fractions, and you take a common denominator, and you go along to this second circle here. But it is quite often very useful in mathematics to go from the right hand side over here, back to this form. And we'll see how we do that. Okay, if we have in general this part here, if we have f of x over ax plus b upon cx plus d, we can say that this thing is identically equal to a over ax plus b over cx plus d. Now this identity sign is very important. Quite often you'll see people, myself included, are writing this incorrectly as an equal sign, but it is an identity sign. So that means it holds for all values. So that is very important, as we will see later on. So how we go through this, we're going to just jump to the example, and we'll talk about key points as we come to them. Okay, so in this example, we're going to say, the first thing we're going to say is let your expression, which was 9 over x minus 5 upon x minus 2, be identically equal to, and that's important, it's identically equal to a over x minus 5 plus b over x minus 2. Now this next step that I'm going to do, I do not normally do this. I normally skip past this, and really ideally it would be good if we can get to the point where we can skip past this. But I will show you this step just this one time. So what we're going to do here is we're going to cross multiply, or multiply cross by the denominator here. So the x minus 5 upon x minus 2 multiplies across. So everything on the right hand side is now multiplied by x minus 5, x minus 2. So that's what you have for the first term. For your second term, it's going to be b upon x minus 5 upon x minus 2 all over x minus 2. Now, what we should see is that this will cancel out. That will go with that, and the x minus 2 will go with the x minus 2 on top, leaving us with 9 is equal to a upon x minus 2. Oh, again, you can see I've forgotten about my identical signs, plus b upon x minus 5. Now, this is the equation that we're going to use. So it's as if everything we've done before hasn't existed, and this is the equation we're going to use to find my a and my b. There's two ways of doing this. The first way is to sub in values. So you can sub in any value at all. So for x, so x equals 1, x equals 2, x equals 3, whatever it happens to be. Or you can equate coefficients. We'll talk about equating coefficients in the next example. So this one we're going to use substitution method. So again, we're referring to this equation here, remember, and I'm going to say let x equal, and I've said we can sub in any value at all, but it's sensible to sub in particular values. So if we look at this bracket, if you put x equal to 2, what will happen in this bracket? It will become 2 minus 2, which is 0, so the a term will disappear. So that's a sensible thing for us to let our x equal to. So we're going to let x equal 2. So you're going to have 9 then is equal to a times a 0 plus b times, and 2 minus 5 will be minus 3. So you really have 9 is equal to minus 3b. So b is equal to minus 3. Okay. Your next thing, same idea, we're going to let x equal, and we'll go back to this one, and here, if you put 5 into this, 5 minus 5 would be 0, so the b term would disappear. So we're going to let x equal 5, and you have 9 is equal to, and that's going to be a times 5 minus 2, which is going to be 3, plus b times 0. So therefore a is equal to, or sorry, I'll say 3a equals 9, therefore your a is equal to 3. So you've got your a equal to 3, you've got your b equal to minus 3. So we'll just say, therefore, our answer is equal to 3 over, and a was over x minus 5, and then the b was minus, so I'll say minus, and then 3 over, and then that's x minus 2. And that's it done. Okay, in this next example, it's just slightly trickier because I haven't factorized the bottom line first. So the first thing I'll do is just say that is equal to 6x over, and that's going to be x plus 2 upon x minus 1. And then it's the same process as before. To start, we're just going to say let 6x over x plus 2 upon x minus 1 be identically equal to a over x plus 2 plus b over x minus 1. And then you cross multiply, and I'm going to leave out the step that I put in last time. So if you think this first term, you're going to have your a is being multiplied by x plus 2 over, x plus 2 upon x minus 1, and then you're dividing by the x plus 2. So the x plus 2's cancel out, leaving you just x minus 1. Likewise, your b is being multiplied by x plus 2, x minus 1, and you're dividing by the x minus 1. So the x minus 1's cancel out, leaving you x plus 2. So this is the equation that we're going to use, or the identity we're going to use to find our values of a and b. Okay, this time we're going to do it a little bit different, and we're going to equate the coefficients. So we're going to say equate the coefficients, and I'll abbreviate this the next time you see me doing this. Equate the coefficients of, and I'm going to just say x. So what I mean by this is the number of x's on the left hand side is equal to the number of x's on the right hand side. So here, equating coefficient of x, I'm going to have 6 is equal to a plus b. Next thing I'm going to do is equate the coefficients of x to the 0, I think we'll go for. So x to the 0 confuses people. So I'll explain what that means. Equate coefficients of x to the power of 0. Your x to the power of 0 is just your numerical terms. So if you look on your left hand side, you have no numerical terms, so it's 0. On the right hand side, you'd have you'd have minus 1 times a, and you'd have 2 times b. So you'd have minus a plus 2b. Okay, you have two equations, dot, 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 call that equation 1, dot, 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 call that equation 2. Two equations, two unknowns. I'm just going to add equation 1 to equation 2, and what am I going to get? I'm going to get 6 is equal to 3b. Therefore, my b is equal to 2. And then we can just do substitution. So we'll just say sub into equation 1. So you sub that into equation 1, and where are we going to have 6 is equal to a plus 2. That means your a is equal to 4. So your answer in this case, running out of space here, apologies. Your answer in this case is 4 over, and the a was over x plus 2, and then my b was 2. So plus 2 over x minus 1. And that's it done. Okay, in this next example, we've got a bit of a problem, because if you multiplied out the bottom line, the order of the bottom line would be 2, because the highest power would be x squared. So, and on the top line, your highest power is also x squared. So we said way back up here, and I didn't really talk about it, if the degree, that means the same as the order of the numerator, the degree of the numerator must be less than the degree of the denominator, otherwise you will need to divide through first. So fractions cannot be improper, so the top line cannot be bigger than the bottom line, basically. So we go back to this example. First thing we need to know here, we'll say need to divide first. So when we say we're dividing, we're going to do our 2x squared plus 5, and we're dividing it by x squared minus 2x minus 8. That's what we're dividing by. So we're going to go through this. A couple of things on this division. Notice I left space here where the linear term would have been, the x term. If you don't leave that space, you will get into problems, so make sure you do, please. So to do this, we're going to look and see we've got x squared. Just think about your x squared. How many times does x squared go into 2x squared? It goes in twice. So that means your 2 lines up here. Now what we're going to do is do 2 times this whole thing, the divider, and then write that underneath. So underneath we're going to have 2x squared minus 4x minus 16. I don't put a wee subtract here, but that's what we're doing. We're doing this line minus this line. So you've got 5 minus 16, which is 5 plus 16 really, which is going to be 21. And then here you've got 0 minus 4. So 0 minus 4 is 0 plus, sorry, I should say 0 minus 4x. So 0 plus 4x, which is just going to be 4x. So that's what you have. Okay, so this means x squared minus 2x minus 8 goes in 2 whole times with this left over. So a wee reminder of what we mean by this. So for example, if I had 37 divided by 5, we know it goes in 7 whole times with 2 left over. So 7 and 2/5. So here, to refer back to numerical example if you get a wee bit confused by these. So that means we have shown x squared plus 5x divided by x squared minus 2x minus 8. It goes in 2 whole times with 4x plus 21, all divided by x squared minus 2x minus 8. Okay, we'll go up here and we've got a wee good bit to do. So far we know it is 2 plus 4x plus 21, but we're not going to write the bottom line as x squared minus 2x minus 8 anymore. We'll write it as it was originally. It was x minus 4 upon x plus 2, dot, dot, dot. We'll call that equation 1. We'll come back to that later on. Okay, we just want to investigate this part of it here. So we don't really care about the 2 at the minute. We just want to express this part of it in partial fractions. So we're just going to say let, and then it's just back to for the time being, it's back to the typical question that we've done before. So 4x plus 21 over x minus 4 upon x plus 2. Let that equal a over x minus 4 plus b over x plus 2. And then that's going to mean that 4x plus 21 is identically equal to a times x plus 2. Skipping through this quite quickly, this one. And then x minus 4. And then we're just going to say let x equals minus 2. So if x equals minus 2, you're going to have minus 8 plus 21 is equal to a times 0 plus b times minus 6. So what you're going to have is 13 equals minus 6b, or b is equal to minus 13 over 6. So that's pretty ugly, but we'll see it's fine when we get to the answer. And then we'll say let x equal, and if you let x equal 4, you're going to have 16 plus 21 is equal to a times 6 plus b times 0. So 16 plus 21 is going to be 37 is equal to 6a. So a, again, pretty ugly, but it's 37 over 6. Don't be writing those as mixed numbers. You'll see why in the next bit, in the final answer. Okay, our final answer. Our final answer then. A lot of people, what they do is they forget about this. All we've done now is we know what our a and b is when we express this in partial fractions. Don't forget about the 2. So that's a big mistake a lot of people make, forgetting about the 2 just. So for your final answer, we're just going to say it is equal to the 2 plus, and then our a was 37 over 6. So that's 37 on the top, 6 on the bottom line. And what was it was x minus 4. And then my b, my b was minus, wasn't it? B was minus 13. So minus 13 goes on the top, and then 6 upon x plus 2 goes on the bottom. And that's it. Now we're going to look at a slightly different problem, and this is whenever you have a repeated linear factor on the bottom line. So here in this algebraic example, we have a function of x. On the bottom line, you have got ax plus b all squared. Now you have to say this is identically equal to a over x plus b over x plus b squared. Okay, and just so you know, had it been different again, so had it been something like I don't know, 4 over x cubed, you would have to say that would be a over x plus b over x squared plus c over x cubed, and that's the way you would have to do it. More often than not, it'll just be quadratic linear factors, but there's no reason why it couldn't be. Okay, I'm going to go on and look at an example of this, numerical example, and it really is very straightforward. So in this example, we've got a repeated linear factor. So your first step is just to say let your 3x plus 4 all over x plus 2 squared be identically equal to a over x plus 2 plus b over x plus 2 squared. Now I'm going to show the step that I very rarely show. I'm going to show it this time just to be so everyone's clear where it's coming from. 3x plus 4 is identically equal to, so all we're doing is multiplying across by the x plus 2 squared. So we're going to have a times x plus 2 squared all over the x plus 2 plus b times x plus 2 squared all over x plus 2 squared. So you can see what will happen and what will cancel out. So my a has a is upon x plus 2 squared, and it's been divided by x plus 2, so that just leaves you with a upon x plus 2. And then you've got b upon x plus 2 squared divided by x plus 2 squared, so that just leaves you with b. Okay, this then is going to be the equation that we're going to be using to solve this thing. So whatever method you want, you can use your equating coefficients, or you can use your just substitution method. I'm going to use both here. So I'm going to say let x be equal to minus 2. So the left hand side is going to be minus 6 plus 4 is equal to a times 0 plus b. So that's just going to be minus 2 is equal to b. And then I'm going to say equate coefficients of x, and I'm going to say 3 then on my left hand side is equal to a. Yep, and that's it. So I've got my a and my b. So therefore I can say 3x plus 4 all over x plus 2 squared is equal to 3 over x plus 2, and then my b was minus 2, so minus, and then 2 over x plus 2 squared. Okay, in the next example, a very common type of question where you've got a combination of the normal sort of method and then the repeated linear factor method. So again here in this one, just say let 2x plus 6 all over x upon x minus 1 squared be identically equal to a over x, and then the repeated linear factor bit, b over x minus 1 plus c over x minus 1, and that one is squared. Okay, so if you cross multiply, or you multiply across by your x upon x minus 1 squared, you're going to be left with 2x plus 6 is equal to a times x minus 1 squared plus b times x minus 1 and plus c times x. So you've got 3 things to find here, so it's a wee bit trickier. Again, use whatever method you want here. I will imagine use a combination of both. Sometimes you just play around with it, and in your head you think I'm gonna just do the substitution method. I'm just going to use the equating coefficients method, and then you change halfway through. So don't just decide on one method. Sometimes you'll see an easy way as you go through it. But I'm definitely going to let my x be equal to 1 to get started. So if you let x equal 1, you can see this bit here will become 0, so your a term will disappear. This bit here will become 0, so your b term will disappear. You'll be able to find your c straight off. So letting x equal 1, you're going to have 2 plus 6, which is just going to be 8, is equal to my a times my 0 plus my b times 0 plus c times 1, so c. So straight off you've got c is equal to 8. Same idea, I'm going to let x equal 0. So if you let x equal 0, that bit's going to be 0. So your b term is going to disappear. That's going to be 0. So your c term is going to disappear. So it's going to allow you to find your a. So just be careful with this. Left hand side, 2 times 1 is 2, plus 6 is going to be 8. Sorry, I'm not doing 2 times 1 at all. I'm doing 2 times 0. 2 times 0 is 0, plus 2 is plus 6 is 6. And then putting your x equal to 0, you're going to be a left with a times minus 1 squared. So that's just 6 is equal to a minus 1 squared is 1. So 6 is equal to a, or a is equal to 6. Okay, we're still to find our b. So what I'm going to do here is I'm going to say equate coefficients of x squared. Now, just before I go on, you could, if you really don't like the equating coefficient method, I would advise you to learn it because you will see it in other times, other bits of mathematics where it's very useful. But here, if you really don't like it and you're determined just to use a substitution, sub in any number at all that you want. So you could have subbed in, if you'd say, I'll rub this out in a minute, but if you said, let x equal 2, for example, left-hand side would be 2 times 2 plus 6, which is 10. And then it's going to be, a times 2 minus 1, which is 1 squared, plus b times 2 times 2 minus 1, which is 1, plus c times 2. So really you're going to get 10 is equal to a plus 2b plus 2c. But you already know your a, and you already know your a, and you already know your c, so you can easily work out your b. Okay, so that would work absolutely fine if you really don't like the equating coefficient method. But let's see if we can use our equating coefficient method to do this. And we're going, as I said, we're going to equate coefficients of x squared. So equating coefficients of x squared, on the left-hand side, you haven't got any x squared terms at all, so you have none of them. On the right-hand side, you've got x minus 1 squared. When you square that out, you're going to get an x squared term times a, so that's 1x squared term. And then x times x is going to give you x squared, so that's times b. So you've got a plus b is equal to 0. So you know your a is 6. So that means minus 6 is equal to b, or b is equal to minus 6. Okay, so we've got that. Your answer then, I'm just going to write the whole thing out again. So x plus 6 all over, what was it, x upon x minus 1 squared is equal to my a, which is 6 over x. My b was minus 6, so just write minus 6 over, and that's x minus 1. And my c was 8, so that's 8 over x minus 1, and that bit was squared. Remember, it was our repeated linear factor, and that's my answer. Done. Okay, our last example is very similar to the previous one. So we are just going to do the same thing. We're just going to say let 2x plus 3 all over x minus 5 x plus 4 squared be identically equal to a over x minus 5, just a normal factor, and then plus b over x plus 4, so that's the first bit of our repeated linear factors, plus c over x plus 4 squared. Okay, again, multiply over by the x minus 5, x plus 4 squared, you'll have x plus 3 is identically equal to a times x plus 4 squared, plus b times x minus 5 times x plus 4 plus c times x minus 5. Again, whatever method you want, you can just use all equatings if you want. You can use all substitutions, or you can use, more than likely what I will do, a mixture of both. So I'm going to say, first of all, let x equal to 5, and I'll have on my left hand side, I'm going to have 2 times 5 plus 3, which is going to be 13, and then I'm going to have a times 5 plus 4, which is going to be 9. I'll just write 9 squared, plus b times 0 plus c times 0. So I'm going to have 13 is equal to 81a. So a is equal to 13 over 81. Very common for these to be ugly looking fractions. Doesn't matter. Doesn't make a button of difference. So just go with it. Next one I'm going to say let x equals minus 4. So my left hand side is going to be minus 8 plus 5, minus 8 plus 3, which is going to be minus 5, and then is equal to a times 0 plus b times 0, and then plus c times, and it's going to be minus 4 minus 5 minus 9. So that means minus 5 is equal to minus 9c. So c, a wee bit of working out, is equal to 5 over 9. So I've got my a and my b. I just have to, a and my c, I just need to find my b. So looking at this equation, I'm just going to say again, I'll just, what will we do here? We will equate my coefficients of x squared again. So equate coefficients of x squareds. So on the left hand side I have no x squared terms. On the right hand side, when you multiply the x plus 4 squared out, you'll have one x squared term, so it's a times an x squared term. When you multiply this middle set of brackets out, you'll have an x squared term, so it's plus b. So that 0 is equal to 13 over 81 plus my b, because we already knew what the a was. Therefore b is equal to minus 13 over 81. So your answer, have I enough space to write their question down? Hopefully. We have got 2x plus 3 over x minus 5 upon x plus 4 squared is going to be equal to, my a was 13 over 81, so you put the 13 on the top, the 81 on the bottom, and then that was times x minus 5. My b was minus of that, so minus 13, and then 81 times x plus 4, just squeezing this in, no more, and then plus 5, and then 9 times x plus 4, and that is squared. And that is it. Okay, if we look down at the wee summary here, just it sums up everything that we have said. The key point here is, remember to divide. If your order or your degree of f of x is the same or greater than that of the function on the bottom line, then you must divide first, and just take care doing that. Okay, there's exercises now up on the Google Classroom for you, so please work your way through those and get in touch with ourselves if you have any problems. Thank you.